Steam generator boiler. Part 1e. Waste heat boiler. Used when waste heat available at medium, high temp. Auxiliary fuel burners used if steam demand is more than the waste heat can generate. Used in heat recovery from exhaust gases from gas turbines and diesel engines. A waste heat boiler can be economically installed wherever waste heat can be available at medium or high temperatures. Wherever the steam demand is more than the steam generated during waste heat, auxiliary fuel burners are also used. If there is no direct use of steam, the steam may be let down in a steam turbine generator set and power produced from it. It is widely used in the heat recovery from exhaust gases from gas turbines and diesel engines. Heat recovery steam generator HRSG, located at the exhaust end of gas turbine or engine. During plant operation, the gas turbine engine discharges a high volume of exhaust flue gas containing a considerable amount of thermal energy. The HRSG reclaims the exhausted thermal energy for the purpose of generating superheated steam for use in the steam turbine generator. Efficient reclamation of the gas turbine exhaust prevents wasted energy, resulting in a significant increase of overall plant efficiency. The installation of the HRSG gives the plant its combined cycle status, in that it represents a major component of the Rankine cycle portion of the power plant. Nuclear steam generating systems. Steam generators are heat exchangers used to convert water into steam from heat produced in a nuclear reactor core. They are used in pressurized water reactors (PWR) between the primary and secondary coolant loops. Nuclear steam generating systems include a series of highly specialized heat exchangers, pressure vessels, pumps and components which use the heat generated by nuclear fission reactions to efficiently and safely generate steam. The system is based upon the energy released when atoms within certain materials, such as uranium, break apart or fission. Fission occurs when a fissionable atom nucleus captures a free subatomic particle, a neutron. This upsets the internal forces which hold the atom nucleus together. The nucleus splits apart, producing new atoms, as well as an average of 2 to 3 neutrons, gamma radiation, and energy. In commercial power plants, steam generators can measure up to 70 feet, approximately 21 meters in height, and weigh as much as 800 tons. Each steam generator can contain anywhere from 3,000 to 16,000 tubes, each about 3/4 of an inch, approximately 19 millimeters in diameter. The coolant-treated water, which is maintained at high pressure to prevent boiling, is pumped through the nuclear reactor core. Heat transfer takes place between the reactor core and the circulating water, and the coolant is then pumped through the primary tube side of the steam generator by coolant pumps before returning to the reactor core. This is referred to as the primary loop. Types. Westinghouse and combustion engineering designs have vertical U-tubes with inverted tubes for the primary water. Canadian, Japanese, French, and German PWR suppliers use the vertical configuration as well. Russian VVER reactor designs use horizontal steam generators, which have the tubes mounted horizontally. Babcock and Wilcox plants have smaller steam generators that force water through the top of the OTS. Gs once through steam generators counter flow to the feed water and out the bottom to be recirculated by the reactor coolant pumps. The horizontal design has proven to be less susceptible to degradation than the vertical U-tube design. Thank you to watching the part 1 of steam generator. Next part 2 will coming soon, which cover the accessories and auxiliaries. Keep watching my channel show views for more technical informative videos.